Alright, this video is about solving trig equations using factoring. Remember to keep your unit circle handy. You're going to need it as you solve these equations. Alright, let's try some examples. Remember, we're finding x, the angle where a certain value occurs on the unit circle. We're finding all the solutions between 0 and 2 pi. So 1 revolution, but we're not going to give 2 pi as one of our answers, since it's also called 0. So here's an example 1. And actually, this one, you could factor it out, but you can just work it the old way, the same way we were doing it yesterday. Okay, so we could do tangent squared x, add 1 to both sides, equals a positive 1. And now we got a squared term, so we have to square root it. So that tells us that the tangent is plus or minus 1. All right, and remember on your unit circle, the tangent's 1 everywhere the angle is pi over 4, something pi over 4. It's either positive or negative 1. Since it's positive and negative, you have to give that angle from all 4 quadrants that has the tangent of 1. So that would mean that x is pi over 4 from the first quadrant, 3 pi over 4 from the second, 5 pi over 4 from the third, and then 7 pi over 4 from the fourth. Okay, so that's not too different than what you did yesterday. Quite similar, in fact. Let's try another one. All right, tangent squared x equals negative square root of 3 tangent x. What's different is you got tangents on both sides of the equation. One is squared and one is not. So what you're going to need to do is move this guy over to the right side. So you're going to start by setting it equal to 0. Okay, so moving everything to one side. So when I do that, I get tangent squared x. When I move it, I have to add, right? So plus square root of 3, square root of 3 tangent x equals 0. All right, we're good with that. Now you only have 2 terms, both have a tangent. So look for a greatest common factor. Okay, what's the greatest common factor between these two? A tangent. If I take a tangent of x out of both of these, I now have tangent of x plus the square root of 3 equals 0. All right. Now we're in a position we can set each of these 2 factors equal to 0. Where's the tangent of x? 0. And this one, where's the tangent of x plus the square root of 3 equals 0. So we have one more final step. We've got to move this over. So we see the tangent of x is equal to negative square root of 3. All right, so now think about your unit circle. And where is the tangent 0? Remember, tangent's y over x. Where is the y 0? That's what makes tangent 0. So where are your y values 0? Well, right here on the x-axis, that's where they're 0. So my x, the angles there would be 0 and pi, right? And over here, look at this. Where's the tangent square root of 3? Remember we talked about the square root of 3 tangents are at the pi over 3 angles. So at pi over 3 angles here, 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 and here, those are where it's square root of 3, the tangent square root of 3. Now, where is it negative? Well, that means the signs are different between the x's and the y. So in quadrant 1, x and y are both positive. In quadrant 3, x and y are both negative. So they have to be the pi over 3 angles in 2 and 4. So what angles are those? Well, that's 2 pi over 3. And then down here in 4, that would be 5 pi over 3. Now, we have 2 sets of answers, so we want to be in good etiquette for math, so we put them in order from least to greatest. So we say 0, 2 pi over 3, pi, and then 5 pi over 3. All right? I'll try to always do that for you, but you need to always put them in order once you get the 2 parts of the solution. Okay, so on this one, you've got to move everything over here on the left, and I get, when I do this, 2 sine squared x minus the sine of x minus 1 equals 0. Now, this is a trinomial, and I'm going to factor it. Now, think of it like old school 2x squared minus x minus 1 equals 0. And you would factor the same way you did back in the day. To what 2 numbers multiply to give you negative 2, but add to give you negative 1. That'd have to be negative 2 and 1. Then you use box method to multiply it out. Okay, so this is positive 2x squared minus 1. These both have an x, and I know that that's minus 2 and a positive 1. Greatest common factor by column gives me an x. Greatest common factor is a minus 1. Greatest common factor to the left here is 2x, and this one would be plus 1. So when I bring them out over here, I'm going to do 2 sine x. I'm just putting the sign back in now. And then I have sine x minus 1 equals 0. So now I have my two equations to solve. All right. So I'm going to move the 1 over to solve it. 2 sine x equals negative 1. Divide by 2. So the sine of x equals negative 1/2. All right, so let's think about on our unit circle, where are the y values negative 1/2? Well, we know they're negative in quadrants 3 and 4, right? And where are the y values negative 1/2? Well, those are the pi over 6 angles down here. So what is that? Well, that would be 7 pi over 6 and 11 pi over 6. Okay. Now over here, let's solve this one. We move the 1 over, so the sine of x equals positive 1. So where on our unit circle is the y value positive 1? Only one location, and that would be at pi over 2. All right, so now we put these in order, remember from least to greatest, so we go pi over 2, 7 pi over 6, 11 pi over 6. So this is your final answer right here. Okay. So now you've seen the 3 different types to solve when it involves factoring. Sometimes greatest common factor, sometimes you have to do FOIL or box. Just look at the problem and decide. Now, there is a way to check your work. So when we do this, if we solve this one, we're going to add 1 to both sides. We get cosine of x equals, or 2 cosine of x equals 1, divide by 2, and we get cosine of x equals 1/2. All right, so where on our unit circle is the cosine positive and 1/2? Well, it has to be over here. Positive 1/2 would be right up here, because it's 1/2 square root of 3 over 2. Okay, it's also down here where that's pi over 3, and down here that would make that 5 pi over 3. Okay, so it had 2 solutions. So how would I check this? Well, now you put this angle back into the original problem. Okay, so I would do 2 cosine of pi over 3 minus 1 equals 0. Well, okay, so now you work it out. What's the cosine of pi over 3? Well, we said it's 1/2, right? Well, 2 times 1/2 is 1, minus 1 equals 0, and it works. Now, can you do it with the 5 pi over 3? Sure can. 2 cosines of 5 pi over 3 minus 1 equals 0. 2 times 1/2 minus 1 equals 0. So again, it's 1 minus 1 equals 0. So both of these are good solutions if you need it. Okay? Let's look at this one. Where's secant of x minus 2 equals 0? Well, secant of x, if I add 2 to both sides, I get equals 2. Now remember, secants are reciprocal, so we take the reciprocal of both sides. Okay, so I get cosine of x, that's the reciprocal. What's the reciprocal of 2? 1/2. Hey, look, we're in the same position we were a while ago. We decided that the cosine is positive 1/2 at pi over 3 and at 5 pi over 3, right off the unit circle. So I can solve this again. The secant at pi over 3, is it, or minus 2, equals 0. Well, if the cosine is 1/2 there, then the reciprocal is 2, isn't it? So I put 2 minus 2 equals 0. That works. Same would work with 5 pi over 3. The secant at 5 pi over 3, well, we know the secant is 2, and that works. All right, one more to show you to check it. All right, this is the one that we solved earlier. And let's just check one answer for time's sake. On this one earlier, we found out that this one, actually let's do two. Pi over 2, 7 pi over 6, 11 pi over 6. Okay? So if I check pi over 2, if x is pi over 2, let's just check this answer and see if it's true. All right? So 2 times sine squared pi over 2 equals sine of pi over 2 plus 1. All right, so sine squared of pi over 2. Well, we got to figure out what is the sine of pi over 2. Well, that's 1. Square it, you still have 1. 1 times 2 is 2, right? Over here, what's the sine of pi over 2 plus 1? Well, sine of pi over 2 is 1 plus 1. So this one works. All is good. Okay? What about if it was the 7 pi over 6 angle? All right, the other side of the equation. So it would be 2 sine squared of 7 pi over 6 equals the sine of 7 pi over 6 plus 1. All right, so we got to get a value here first before we square it. So what is the sine at 7 pi over 6? Well, we said earlier that that was a negative 1/2. And we got to square it. Okay, so negative 1/2 times negative 1/2 is 1/4, positive 1/4, times 2 gives me 2/4, which is also known as 1/2, right? Okay, so what about on the right side? Well, what's the sine at 7 pi over 6? We said that as negative 1/2 plus 1. So what do I really have? I have 1 minus 1/2. What's left over is 1/2. So either solution I use, I could even do this with 11 pi over 6. Any of the solutions should work, okay? Just to give you a clue how this works, alrighty? Okay, so come with your questions to class and we'll go over more examples if we need to, alright?